This is a Friday Shoes production. Today's lesson is 4-10 in our books and on page 236. And our target is I can solve problems involving scale drawings. Scale drawings and models, or what we like to call scale models, are used to represent an object that is too large or too small to be drawn or built at actual size. The scale, which we'll be talking about today, is the ratio of a length on a drawing or model to its actual length. And there's a couple examples they have here. You might say that 1 inch on the model is 4 feet in real life, or 1 unit represents an actual distance of 30 units. This one is the one that doesn't have units on it. And basically, distances on a scale drawing are proportional to distances in real life, which means they're proportional, and we can use, which means we can use proportions to solve them. Let's take a look at this first one here. Here's our scale drawing. You've maybe even done this if you've ever traveled using a map. First question, use the map to find the actual distance between Grenada, Mississippi, and Little Rock, Arkansas. You see the yellow line there I've drawn for you. Well, the distance on the map, if you measured it there, is about 5.2 centimeters. So what do? Simple. We will let x represent the actual distance to Little Rock, and we create our proportion. Now notice, we're going to take the key, which is 1 centimeter is to 50 kilometers, and that's right there. And then we're going to, on the top, put the centimeters down, the 5.2 centimeters that we know that we've measured. And we're going to say, hey, how far is that in kilometers? Cross multiply, find our cross products, and then divide. In this case, we don't have to divide, we'll divide by 1. Let's keep it the same. So it's roughly 260 kilometers. That's probably the best way to describe this and how to do it. There is a second version there, and you can read it at your leisure if you like. It's basically figuring it out how many kilometers per centimeter, and that's 50, and then you just multiply that by how many centimeters you have. You get the same answer. It's 260. All right. How about you try it? Come on back, see how you did. It says use the map shown to find the actual distance between Charlotte and Spartanburg. Measure to the nearest quarter inch. All right, take a look at the key. There's our scale. And I've already done the measurement for you. It's about 2.5 inches right there. So step 1, we got about 1 inch is 25 miles. And then I measured it for you. It's 2.5 inches. So how far is 2.5 inches in reality? It's about 62.5 miles. And I kept that there, but this is the actual answer. It's about 62.5 miles. All right, how about finding the scale? One of the models of a dinosaur used in the filming of a movie was only 15 inches tall. In the movie, the dinosaur appeared to have an actual height of 20 feet. What was the scale of the model? Let's see what we do here first. Let x represent the actual length of the dinosaur in feet. And here's what we have. So we have 15 inches is 20 feet. Where did they get that? Well, there's the model, and there is the actual height. So then on the model, if we have 1 inch, how many is that going to be in actual size? Well, notice what they've done. When we create a scale, we want to have 1 right here. So all we're doing is ending up dividing by 15. So if you notice in the math, we're going to do our cross products like this. Here we are. And in the end, you actually just take 20 and you divide by 15. And when you do that, you have 1 1/3. So the scale is 1 inch is equal to 1 1/3 feet, which is 1 foot 4 inches. Now, this tip here tells you that scales and scale factors, which we're going to talk about, are always written so that the drawing or model length comes first in the ratio. Meaning we always put the, hey, what's the model length we're looking at? All right, you try this one. Come on back, see how you did. It says the model Mr. Vicario made of the building he designed is 25.6 centimeters tall. If the actual building is to be 64 meters tall, what is the scale of his model? Well, step one, take the two pieces of information and create your ratio there. 25.6 centimeters to 64 meters. Should say that is our going to be our scale, but we have to then divide to get 1. We want to know what 1 centimeter would be in the real world. So we divide by 25.6. Doing so, we end up with 1 on top, and we end up with 2.5 on the bottom. So we would say the scale for this would be 1 centimeter is actually equal to 2.5 meters. All right, scale factors. This is a little bit more in depth. It says the scale factor for scale drawings and models is the scale written as a unitless ratio, meaning there's no unit on this, in simplest form. The scale should be converted to the same unit of measure before dropping the unit. Basically, units cancel out. So it says, number 3, find the scale factor. Find the scale factor for the dinosaur model in example 2. Well, if you remember, it was 1 inch is 1 1/3 foot. Now, feet. Now, if you notice, you have to convert 1 1/3 feet into inches by multiplying by 12. And when you do that, you get 16. So there's actually 16 inches in 1 1/3 feet. Now, if you remember, I said it was 1 foot 4 inches. That's 12 inches plus 4 inches, 16 inches. So notice, we now have the same unit. In the beginning, we didn't. Now we do. So you do need to know a little bit about your conversion units before you can actually convert. So the scale factor is 1 over 16, or 1 to 16. This means that the dinosaur model is 1/16 the size of the dinosaur's appearance in the movie. That means that the movie is showing it 16 times bigger than really what it is as a model. All right, how about you try the scale factoring on these, C and D. Stop the video, come on back, see how you do. All right, step 1. You notice that 1 inch and 15 feet, that'd be 1 to 15 feet. We can't do it because we have to, or 1 inch to 15 feet, we can't do that. We have to have the same units. So we have to convert 15 feet into inches. So you all know that 1 foot is equal to 12 inches, hopefully. So we take 15, because we have 15 of those feet, times it by the 12 inches per, and we have 180 inches, which is 15 feet. From there, we take 1 inch and put it on top. We take 15 inches, put it on bottom. So what we did was we took 1 inch, put it on top. We took this 180 inches, which is this 15 feet, put it on bottom. We reduce, we don't have to because 1 is already on top, and we have a scale of 1 to 180, or you can write it with the colon, 1 to 180. All right, let's take a look at D. Same situation. We have centimeters and meters. We have to convert. So, convert 2.5 meters into centimeters? Simple. Use 1 meter is actually equal to 100 centimeters. Talked about that in class. 2.5 times 100 centimeters, so we have 2.5 of those meters, is 250 centimeters. So now we take the 10 centimeters, place it right here, take our 250 centimeters, place it right there. But this one we do have to reduce. Notice the top is not 1. So we're going to divide the top and the bottom by 10. And in the end, you'll notice we have 1 on top and 25 on bottom. So we have 1 to 25, or colon, 1 to 25. All right, let's take a look at this fourth example here. Construct the scale model. Statues. The Statue of Liberty stands about 305 feet tall, including the pedestal. Altogether, it's 305 feet tall. Christina wants to build a model of the statue that is at least 20 inches tall. Well, what do? First off, find the scale if the model is 20 inches tall. So we have 20 inches is the model, and then in actuality, it's 305 feet. So the scale then, divide the top by 20, divide the bottom by 20, and we have 1 inch is representing 15.25 feet. So that would be our scale. The scale is 1 inch to 15.25 feet. Using the scale, find the height of the pedestal on the model if the actual height of the pedestal is 154 feet. All right, what do we do? Take our scale, use that right there. Then we're looking for how many inches it would be, because we already know that the actual length or height is 154 feet. Of course, we cross multiply, and you can see that we have 1 times 154, 15.25 times x. We're going to divide both sides by 15.25, and we get 10.1 inches. The height of the pedestal in the model should be at least 10.1 inches. All right, let's go on down. Let's give it a try for yourself. Pause the video, come on back when you're done, see how you do. All right, Kalia is making a model of a cross-section of Earth. He wants the core to be less than 10 inches in diameter. The actual Earth core is about 1,500 miles in diameter. Choose an appropriate scale and use it to determine the diameter of his model if the diameter of Earth is 7,926 miles. Now, using exactly what we did previously, step 1 is, let's find the scale using this 10 inches. So we take our 10 inches here, and we place it over our 1,500 miles. And when we do that, we still have to divide by 10 because the top is not 1. And we end up with, it's in there somewhere, 1 over 150. Which means 1 inch is actually 150 miles. All right, now we have to we're going to use this information now to calculate the diameter. So what do? Again, take our wonderful scale, plug in what we do know. We do know the actuality. We're looking for D because they gave that up here. That's the actual diameter of the Earth. And when you calculate that out, we have 53 inches. Now, you might say to yourself, that seems pretty big. If he's making a model, 53 inches, it's about your outstretched arms. So we might draw the scale a little bit larger. So we might have to convert it. But in this case, I'm going to keep it as this, because that's exactly how I did it up at the top. Don't forget, you can always watch this video again, or read the examples in the book, which these are. Or you can watch some of the personal tutor videos on the online textbook. This has been a Friday Shoes production.